All right. Okay, we're going to be doing graphing linear equations today. That's 3-2 and 3-3 intercepts of lines. So, a linear equation in two variables, well, there's two forms of it. Here is the slope-intercept form, y equals sx plus b. This is called the general form, ax plus by equals c. This one's called the general form because you can describe vertical lines with it, but you can't describe them with this. Well, either way, a graph as a straight line like this. Now, there's two simple forms. Y equals a constant. That graph is a horizontal line. The y equals 0 line is the x-axis. The y equals 1 line is lifting up the axis by 1 unit. The y equals -1 line is the x-axis lowered by 1 unit, and so on. The x equals constant, that equation graphs as a vertical line. X equals 0 line is the y-axis, vertical. X equals 1 is the vertical line, move 1 to the right. X equals -1 is the vertical line, move 1 to the left. All right, let's see. All right, now you can test if a point given on by coordinates is on a line given by a linear equation, and by substitution. For example, is 2, 3 on y equals 7x plus 3? Okay, fine. Well, y is here, 3. The left side is 3. The right side, you plug in 2 into 7. You 7 times 2 plus 3, that's 17, which is not 3. So this point is not on this line. Is 217 on 7x plus 3? Well, okay. The left is 17. The right, you plug in 2 for x, twice 7 times 2 plus 3 does make 17. So yes, these are equal. So this point is on the line given by this equation. Here have the equation, the point 5 by 1. Is it on the line given by 2x plus 3y equals 16? All right, we plug in 5 for x and 1 for y. So the left side is 2 times 5 plus 3 times 1. That's 10 plus, oh dear. That should be a 3, not a 13. So that's 13. Oh my God. Oh, well, it's 13, but the right side is 16, so that's not correct. Excuse me. I'm going to have to, well, do two things. One, I'm going to have to write this down. And also, I'm going to have to, well, okay. It's a 3. And I'm going to have to throw out this cat. So, okay, excuse me for a moment. Hey, cat. Treats, get them every time. They're so gullible. The cat and I have each other well trained. We proceed. So, all right. So 5 by 1 is not on the line given by 2x plus 3y equals 16. How about the point 2 by 4? Is it on the line given by 2x plus 3y equals 16? Well, we plug 2 and 4 in. So 2 times 2 plus 3 times 4, that's 4 plus 12 is 16, which is the right side. And yes, so 2 by 4 is on the line given by this equation. All right. Here we have a line given with my point slope equivalent form, slope intercept form. Y equals 3x minus 2. To graph that, we'll use a table of values. We'll plug in a couple of values for x, and you have a certain amount of freedom in choosing x. And for each x, you can calculate the corresponding y. If x is -1, 3 times -1 minus 2 is a -5. If x is 0, 3 times 0 minus 2 is a -2. When x is 1, 3 minus 2, that's 1. When x is 2, 3 times 2 minus 2 is 6 minus 2 is 4. So you have the point -1 by -5 here, 0 by -2 here, 1 by 1 here, and 2 by 4 here. Okay, these are 4 points, and you draw the line between them, and there you go. You don't really need more than, well, strictly speaking, you don't need more than 2 points. But, you know, sometimes it's good to have a little more for backup. Also, you don't want them to have too close together because then they get in each other's way. Oops, sorry. All right. All right, so we have some examples. Is 2, 6 on the line given by 7x minus 2y equals 3? Plug in 2 and 6 for x and y. 7 times 2 minus 2 times 6, that's 14 minus 12. That's 2, but that's not equal to the right side 3, so no. This point is not on this line. Is 0 by negative 1 on the line x plus 12y equals negative 12? Well, the left side is x is 0 plus 12 times y, 12 times negative 1. 0 minus 12 is a negative 12, which does equal the right side. So yes, this point is on this line. Here we have a substitution issue. If y equals negative 5x minus 4 and x is negative 3, then what's y? Well, okay, you plug it in. For negative 3 and for x, so y is negative 5 times negative 3 minus 4. Negative 5 times negative 3 is 15. 15 minus 4 is 11, and there, that's the value of y. Now, this is a little more tricky because here we're given a general form, 4x minus 5y is negative 4, and we're given y, and we have to find x. So what we'll do is we'll have to actually solve for x. It's not just it's a substitution, but then you have to do some algebra. Plug in 4 in for y, get 4x minus 5 times 4 equals negative 4. This is a 20, so 4x minus 20 equals negative 4. Add 20 to both sides. 4x equals negative 4 plus 20. That comes out to 4x equals 16. Divide both sides by this 4. Isolate the x. Get x equals 16 over 4, or x equals 4. All right, here we have graph y equals x. That's a simple enough thing. And okay, so we make a simple table. X is negative 1, 0, and 1. Y is the same thing, negative 1, 0, and 1. So here's the point negative 1 by negative 1, like here. Here's the point 0 by 0, as in here. Here's the point 1 by 1, as here. And it's a diagonal line. Going to right, it goes from lower left to upper right at 45 degrees through the origin point. Here's graph y equals negative x minus 1. Okay, I have some leeway in what your x's are, and so I chose these for convenience sake. So I have x is negative 2, negative 1, and 0. If x is negative 2, then minus a negative 2 minus 1 is 2 minus 1 is 1. Negative 2 by 1. When x is negative 1, minus a negative 1 minus 1, that's 1 minus 1 makes a 0. So we have negative 1 by 0. When x is 0, y equals 0 minus 1 is a negative 1. 0 by negative 1. So it's this diagonal line this way, going downwards at 45 degrees, going through 0 by negative 1. We have some more. Y equals 1.5x minus 4. Now this 1.5 is a little annoying because it has a fraction in it. And so I made x be multiples of 2 just to cancel out that 0.5. So x would be negative 2, 0, or 2. When x is negative 2, 1.5 times negative 2 is negative 3. That minus a 4 makes a negative 7. So negative 2 by negative 7, this point here. When x is 0, this term cancels and you get y equals negative 4. 0 by negative 4, this point here. When x is 2, 1.5 times 2 is 3. 3 minus 4 is a negative 1. So 2 by negative 1, this point here. So you draw this line here, and there you have it. Here's the equation. 8x plus 4y equals 16.
Sorry, I had a question about number 61.
61?
So basically, you're just plugging in x, and then
Yes.
you're putting y.
Yeah, you plug in values of x, get values of y, and plot the resulting points.
Okay.
I chose these even numbers just to make whole numbers for y, for convenience sake. Okay? I'll take that as a yes. Now here we have this equation here. Now what I'm going to do is I'm going to solve for y in terms of x. So first I transpose 8x, so 4y equals negative 8x plus 16. Divide both sides by 4 to get y by itself. Negative 8x over 4 is negative 2x. 16 over 4 is 4. Y equals negative 2x plus 4. This is equivalent to this. And then you can just substitute in for x. X is 0, 2, or 4. When x is 0, plug in 0. Get 0 by 4. 0 by 4 at this point here. When x is 2, negative 2 times 2 is negative 4. Plus a 4 makes a 0. 2 by 0, this point here. When x is 4, negative 2 times 4 is negative 8. That plus 4 is negative 4. So 4 by negative 4, this point here. And I'm sorry, this really should be a little bit straighter. Maybe I should fix that in the notes. All right, after this. 326. Oh, it's okay. Another equation. Y equals negative 2x plus 1. Okay, fine. Try some values of x. When x is negative 1, negative 2 times negative 1 is 2. 2 plus 1 is 3. Negative 1 by 3, here, this point here. When x is 0, this term cancels. You get y equals 1. 0 by 1. 0 by 1, this point here. When x is 1, plug it in here. Negative 2 times 1 is negative 2. Plus 1 makes it negative 1. So 1 by negative 1, this point here. 83 is sort of a throwback. Here we have h equals 5p. And the book would have you just draw the line h equals 5p. And then try and use that graph to estimate what h is when p is 25. That's ridiculous. It's more carpentry. It's a simple enough matter. If h is 5, p and p is 25, then you substitute. H is 5 times 25, that's 125. Using a graph to find out h is just the wrong way to go about it. But sometimes the book asks these silly questions. Okay. All right, I'm going to pause this one.
Would you want us to graph that out?